Hello and welcome back. And now we want to talk about temperature. And I know that you're saying, well, what in the world does temperature have to do with light? Well, we're going to find out. So we got to know about temperature first. And so temperature is going to be related to the kinetic energy of molecules. So now we got to know, well, what was kinetic energy? So if we go back to lesson number 5, we learned that kinetic energy is 1/2 mv squared. So it's related to the speed of the molecules. So kinetic energy is related to the mass of the molecule. So the bigger the molecule, the more kinetic energy it's going to have. And then it's related to its speed. So the faster it's moving, the more kinetic energy it's going to have. So let's pretend that we have some water, maybe. And so here are some water molecules. And then each of these water molecules has a certain speed. And so let's say that that particular water molecule is going in that direction. And then this one is going off in this direction. And then this one is going off in this direction. Do you notice that the arrows are different sizes? So that means that this molecule is moving faster than this one, at least until it runs into something. So when it runs into another molecule, let's say this one, it could cause this molecule to go off in this direction with a different speed. So you've got all of these different molecules of the water traveling at different speeds, and therefore they have different kinetic energies. But when you average them all together, you would have a certain kinetic energy. Okay, now let's say that we heat the water up with a candle or something. So if we heat the water up, then the molecules start to move faster. They have more kinetic energy, and therefore they would have a higher temperature. So the temperature is proportional to the average kinetic energy of these molecules. The higher their temperature, the faster that they're moving. So let's take a look at this picture here, which is of 2 thermometers. So the first thermometer is in some, let's say, room temperature water. And those blue molecules, they're just not moving very fast. But the yellow ones, though, so now let's say that that is very hot water, and they're going to be moving faster because they're at a higher temperature. And when they hit the sides of the thermometer, they give some of their energy to the material that's in the thermometer. Now, in the olden days, it was good old mercury that you had in your thermometer, and then when your thermometer would break, you could play with the mercury. No, don't do that, because mercury goes through your skin and it can harm your body. So nowadays thermometers use alcohol. So anyway, you take your thermometer, you put it in the boiling water, and the water molecules are moving very fast because they've got a high temperature. They hit the sides of the thermometer, and they give their energy to the alcohol in the thermometer. And you know that hot materials, they do what? They expand. So that alcohol will expand up the column, and then you can put numbers on the column to tell you what the temperature is. So that's how a thermometer works. Well, all right. The important thing is here's 3 thermometers. There are 3 temperature scales. Now the oldest of the 3 is the Fahrenheit scale. And so on the Fahrenheit scale, water would freeze at 32 degrees Fahrenheit, and then it would boil at 212 degrees Fahrenheit. So everybody was happy with that until they came up with the metric system. And so when they came up with the metric system, everything's based on tens in the metric system. So they said, let's make the freezing point of water 0, and then let's make the boiling point of water 100. degrees Celsius or degrees centigrade. It's the same thing. So you remember centi means 100. So that centigrade means that there are 100 of those things in going from freezing to boiling. Well, but then there was a scientist that raised his hand in the back of the room and said, yeah, but did you know that you could make things colder than 0 degrees Celsius? And so the scientists of their day went, oh! And they had to do it all over again and said, okay, how cold can we possibly make something? And so we're not going to get into it, but it turned out that they found it would be negative 273.15 degrees Celsius. And they said, okay, let's start all over again. Let's call that 0. The absolute coldest you can make something, they called it absolute 0, 0 Kelvin. And then they're still kind of using the metric system because you notice that 0 degrees Celsius now becomes 273.15 Kelvin, and that 100 now becomes 373.15 Kelvin. Okay, so how do we convert from Fahrenheit to Celsius and Kelvin? Well, we use Google. Yes, you can. So yes, you can use Google. If you want to know how many degrees Celsius is 10 degrees Fahrenheit, go to Google, type in 10F and then a C, and it will convert it for you automatically. But I want you to know how to do it mathematically. So the first formula tells you how to calculate the temperature in Celsius if you know the temperature in Fahrenheit. So T sub F, temperature in Fahrenheit. The second equation tells you how to calculate the temperature in Kelvin if you know the temperature in degrees Celsius. So let's try it. What is 50 degrees Fahrenheit in Celsius? So write down what you're given and what you're looking for. So we know the temperature in Fahrenheit, and we're looking for the temperature in Celsius. So we take our formula, we plug in, instead of the temperature Fahrenheit, we put in the 50. So 50 minus 32 is 18. And then 18 divided by 9 is 2, and then 2 times 5 is 10. So you're ending up with 10 degrees Celsius. Don't forget to put on your unit. So if you're doing this on my test and you forget to put the unit on there, I'm going to take off a half a point out of 5. So not enough to kill you, but it is going to be enough to make you very annoyed at me that I'm doing stuff like that. So remember to put the units on the end of it. Now let's say I want to know what's the temperature in Kelvin. Well, our formula says take the temperature in Celsius and add 273 to it. So if I add 273 to 10, I get 283 Kelvin. Put a K. You don't put the little circle thing. So you just say 283 and then put a K on the end of it. All right, in our next segment, we are going to go, here's your typical temperatures in Kelvin. So in our next segment, we're going to learn about electric stoves and how they are related to stars. So I'll see you in the next segment.